Hello and welcome to an overview of NDT Care version 3.0 software. For more information, please contact us using the information provided on this slide in the lower left corner. The capability of NDT Care version 3.0 software will be discussed here. First, in terms of display, we will show loss of metallic cross-sectional area, also called the LMA signal. We'll also show the localized flaw or LF signal, an interactive display of wire rope roughness or WRR data, which is a unique feature that allows the accurate quantitative assessment of the number of external and internal broken wires, single and in clusters, including inter-strand nicking, also the severity of corrosion pitting. We'll also show histograms including automatic identification and marking of rope sections with inspector-specified deterioration levels. As part of this analysis, we'll help the user identify and eliminate inspection artifacts caused by, among others, the so-called echo effect that adversely affects the accuracy of LMA signal calibrations for all sensor heads of the clamshell design. Movement of large steel objects in the immediate vicinity of the sensor head, spurious permanent rope magnetization, the end effect that occurs, for example, near wire rope terminations such as sockets, etc. Varying load conditions, stop, go, reverse operations. We also have the capability of doing signal calibration and level adjustment, and providing distance-aligned summary plots for reporting. In terms of a case study, we are going to investigate a 32 millimeter diameter locked coil rope. I refer you to the paper cited at the lower left-hand corner of the screen for more details about this case study and a comprehensive background on wire rope roughness. Given this construction, we looked at a rope that had been mounted on a mobile winch and was in service for approximately 10 years. Visual inspection of the rope showed corrosion in the first and second layer of the rope, as well as corrosion in the second and third layers. Using the data obtained for this rope, we can now use the NDT Care version 3.0 software to analyze this rope further. We'll start by opening the data file and displaying the LMA and LF data. We start the NDT Care version 3.0 software by double-clicking the icon that will have appeared after the installation process. A welcome screen appears. We can now open the file. I will choose an ASCII type as the file was saved in that format. I'll pick this rope and select Open. When the file has been loaded, a message appears in the dialog box. You'll only need to insert time markers if the distance counter signal is either missing or corrupted. For this file it is not, so I will select on Display LMA LF Charts. A pop-up menu will ask to select the number of meters of data to display per page. The file opened is 26 meters long. An overview plot will automatically appear on the first page. So given that the rope is 26 meters long, I'll pick 10 meters per tab. It will then ask if you'd like to display the data in a forward or reverse direction. I will select forward. Another pop-up menu asks if you wish to scale. We can scale. For now, I'm just going to hit OK. And we'll accept those settings. Please note that there are multiple tabs as selected with roughly 10 meters per tab. Again, the overview tab shows the entire 26 meters, and we can show a zoom function of the signals with the tab selections. For now, we'll just focus on the Overview tab. I want to first bring your attention to the upper plot, which is the LMA signal. Note that this axis is scaled and can be calibrated in terms of percentage loss of metallic cross-sectional area, or percent LMA. The lower plot is the LF signal. Note that the scale of this plot is arbitrary. The LF signal is qualitative only and cannot be calibrated. Therefore, it cannot be used to determine or estimate the number of external or internal broken wires, single and in clusters, and the severity of corrosion pitting. As a consequence, it cannot be used to make rational rope retirement decisions. This has been amply demonstrated by impartial and independent round-robin tests. I want to bring your attention to this save figure. Once we click this copy to clipboard, whatever the current figure displayed will copy to clipboard, and then we can paste that into either Microsoft Word, PowerPoint, or other programs for reporting purposes. If we were to click on the tab version and hit Save Figure Copy to Clipboard, this one will be saved. We'll demonstrate that later. We can enhance the LMA data to reduce or eliminate various inspection artifacts caused by the inspection. To do this, the user will select LMA Enhance from the drop-down menu, then select the appropriate sensor head. For this case, the LMA 300 sensor head was used. Scaling can be adjusted. For now, I'll just hit OK and accept the settings. To see what the enhancement does, I will toggle back and forth between this figure, which shows the LMA Enhanced, and the previous figure, which is just the charts. So toggling back and forth, if we look at roughly the 10 meter mark, where there is a calibration wire of roughly 1%, here is the figure without enhancement, here it is with enhancement. A comparison of the echo effects can be seen by looking at this part of the signal where the echoes have been eliminated at both the left and right side. Again, going back and forth, there you see echoes around the calibration wire. Here you can see that the echo effects have been removed. After the signal has been enhanced, we can perform a post-calibration function. This is done by selecting Post-Calibrate from the drop-down menu, and notice a series of crosshairs appear. First, what we'll do is select the bottom of the calibration wire, located roughly here. Notice that a red asterisk appears showing you where you've selected. We can select the top with a second mouse click, and that will select the top of the calibration wire. Now the distance between the two red asterisks is shown here at roughly 0.66187%. Now our desired LMA for calibration, maybe we want 1%. Again, you could put in 1.5 or 2 or whatever you desire. For now, I'll leave this at 1%. And what that will do is adjust the signal. So you can see here that the signal goes from 0 to 1%. We can adjust scaling. Again, I'll just select the defaults and accept those settings. So we have now post-calibrated the signal. I can then level adjust the signal by selecting level adjust from the drop-down menu. My crosshairs appear, and what we'll do is select this point right here where a red dot will appear, and what we want to do is that is the current level selected at 0.38849, and we wish to set the desired LMA level to a 0 reference. Again, you can set that to any value you want, but by default we'll set that at 0. And notice at that point, which is roughly here, has been calibrated, level shifted down to 0. And our calibration wire has still remained at 1%. Again, we can select axis scaling if we wish and hit OK, and then we can accept those settings. So now we have a level adjusted, calibrated, and enhanced signal that we can now perform our wire rope roughness analysis on by selecting WRR from the drop-down menu. A pop-up menu appears referring to the reference scan length in units of millimeters. This length is typically chosen to be equal to the rope lay length. The lay length is approximately 6.25 to 6.5 times the rope diameter. Given that the rope that we used is a 32 millimeter rope, we'll take that roughly times 6.25. That will equal about 200 millimeters. I will enter 200 here and hit OK. We can adjust the axis setting. For now, I will hit OK and accept. Once the data has been entered, a new figure appears showing the enhanced LMA, level adjusted and calibrated signal in blue. The signal riding on top of that in green is referred to as our maximum BLMA signal. For more information on that signal, please refer to the paper previously cited. Next, down below is our WRR signal in black with a skyline plot riding above that in green, which is essentially a reference envelope of the WRR signal. Note in the middle of the graph is a slider which refers to as scan length in unit of millimeters. This is the same scan length that you had previously entered. Notice that the slider will go to roughly 1/100th of the value we entered, or in this case a value of 2, up to 5 times the value we've entered, or a value of 1,000. Please note that the slider tool is currently under development in a beta form, and that we encourage you to discuss the use of this tool and the associated results with an NDT Technologies engineer. Similar to the broken wire discard criteria specified in ISO code 4309, we have allowed the user the flexibility to explore over the range as specified in the ISO code. Note that the wire rope roughness signal here on the y-axis is calibrated together with the LMA signal also as a percentage of rope metallic cross-sectional area, or %WRR. Before I use this interactive tool, I want to draw your attention first to the LMA signal. Notice that at roughly 3 and 5 meters, looking at the x-axis, you'll see these dips in the LMA signal. This signal indicates winding on drum damage with a superimposed higher frequency signal, which is caused by corrosion pitting. At roughly 23 to 24 meters, you'll notice a dip in the LMA signal. This is referred to as corrosion-assisted LMA. Note that corrosion products do not show in the signal, but instead you do see a loss of metallic cross-sectional area as well as the high-frequency corrosion pitting. We will now investigate the interactive slider tool. I can interface with the tool in a variety of ways. I can click the arrows here. Notice it jumps to 210. Click it again to 220. I can also click and drag this. For example, drag it to here. It will update, and here you'll see 620. As I drag that, notice the title of the figure changes to reflect that 620 and also the scan length on the WRR signal. I can also enter in a value by highlighting it and selecting. I'll just select 350, hit enter. That will adjust the slider as well as adjust the title and labels on the WRR axis. As we click the slider, please notice the impact to the wire rope roughness signal below. As we move farther to the right, the length gets wider and the impact on the wire rope roughness signal can be seen. I'll scroll it all the way to the right. Going all the way to 5 times the lay length shows more or less the full winding on drum damage in the WRR trace. As I scroll to the left, notice what happens to the WRR signal. More of the high frequency data can be seen, which would be more of the corrosion pitting. We can bring the signal all the way to roughly 1/100th, and notice the signal is pretty much off the page, meaning that the max BLMA signal and the LMA signal are essentially the same. We can reset to the actual lay length of 200 by entering it in as shown. When we're all done, all we need to do is save the WRR settings. Notice before we do that we also have various tabs. So if we wanted to see either at the winding on drum damage at roughly 3 or 5 meters, we can select this tab and experiment with the slider and see a little bit more resolution on the WRR signal here as we scroll through. I'll go back to the overview page and notice whatever we do on one page translates to the other pages as well. I will now select Save WRR Settings. As a reminder, as we go through, we have a log of the actions that we have taken. As part of that log, it tells us, for example, when we did enhancement, the sensor head that we used, so we can remind ourselves what we used, as well as the scan length of 500 millimeters, which is what we saved. We can now look at providing summary plots for reporting purposes, which shows the LMA in %, LF, and WRR signals. This is an opportunity yet again to change the axis settings. I will do this at least once here, that way you see them. I think our lower signal of -5 is good. Our upper signal, I will go to 1. Our LF, I will go from -1 to 1, and we'll leave the WRR settings the same. So here you can see that we've changed the settings. If I want to redo, I simply hit redo, otherwise I can hit accept. It will then populate the various tabs, and all the settings will be the same on all those tabs. At this point, I will hit histogram from the drop-down menu. When I hit histogram, notice we have a set of crosshairs. So what I will do is select a lower and upper limit over which will display the histogram data. I will select roughly 1 meter as the starting point. Notice that a light blue line appears just as a reminder of where I've selected that, and I will go to a little bit over 25, maybe 25.5 here. It will again give us a chance to adjust the axis settings. I will hit OK and accept. And then a pop-up menu appears which reads, do you wish to set a maximum deterioration zone for the LMA histogram? I will select yes. Another set of crosshairs appear, and I will look at my LMA histogram. A quick review of the data that we're looking at. On the left side are the summary plots of the LMA, LF, and WRR signals. On the right are the histograms which have been performed between the two light blue bars that we had previously selected. I can now set a maximum deterioration zone as, for example, anything less than roughly -1%. It'll give you the opportunity to either accept or redo. First, we make the signal turn red at the value below which we have selected on both the histogram plot as well as the summary plot for LMA in percent, only between the limits that we had previously set. I will show you a quick redo. It clears the graph. Maybe I want it at less than 0.5%. So I will select here, roughly 0.5%, and you can see the update. So I will accept this. It then says, do you wish to perform maximum deterioration zone for the LF histogram? I will select yes. Now notice that the histogram for LF is centered usually about 0, with values going either below or above. I will select a value at roughly 0.25. We will do this symmetric about the 0 point on the y-axis. So any value above 0.25 or below -0.25 will show on both the histogram as well as the summary plot in red. I will redo. Remember, before I hit the top, I will also show if we were to pick that same value on the bottom. I will accept. It will then say, do you wish to set a maximum deterioration zone for the WRR? I will select yes. And for this case, I will select roughly 3/4. We can either accept or redo as done before, so I will hit accept at this point. I will move this off screen for a second just to show you a summary of the histogram. So we have the summary plots again between the two markers that we had selected. Anything to the right or left, notice, is not included in the histogram analysis here. We can zoom in on various features. So again, if I want to look at this winding on drum damage at roughly 3 to 5, I can see that in a little bit more detail here. Please note that even though I zoom on the summary plots, we're showing the exact same histograms on the right. These histograms are not for just the data shown here, but instead the entire histogram for the entire plot. We're just allowing a zooming function so you can see. We can go to the next tab, and finally towards the end. And again, you can see to the right of the mark, none of the signal is in red because it is excluded from the histogram analysis. I'll then go back to the overview plot. I would now like to show a new feature within NDT Care, this drop-down called Save Figures. What this will do, as I click it, a new pop-up menu will appear asking you to select figures to print. Now what we do as we select these, and for now I'll select all of them, but you may wish to only select some. For now I'll select all. When you select this, what will happen is these taskbars will go, and we will go through and save every tab on every figure. As you can see, the tab scrolling, these will save these images as JPEG files in a folder that we'll see shortly. So it cycles through every plot. When it's done going through, all of the figures have been saved as JPEGs. Then a new pop-up will appear asking if you wish to save this to Word. I'm going to say yes. When the windows close, we are all set. Going to here, that creates a folder called Saved Figures. I will view these as details. And what you'll see is I have all of the JPEG files of the plots. So the histogram, I have the overview plots and then the 3 tabs, the LMA enhanced overview plot and 3 tabs, etc. Then at the end, you'll see I have a document called test results, which is a Word document. I will double click to open that. I will zoom to 200% so you can see resolution. And what you'll see is all of the charts put in to a Word document in order. So first you have the overview, the LMA, LF charts. This was the first analysis we did, followed by the first tab where you can see the zooming, the second tab where you can see the zooming, and then finally the third tab. So we have all 4 LMA, LF charts. Then we did LMA enhancement with the sensor. So you'll see the overview and then the 3 tabs as I scroll through. The first tab, the second tab, and then the third tab. After the enhancement, we did post calibration. So again, the overview, the first tab, the second tab, and then the third tab. After post calibration, we did level adjustment, overview, and then the 3 tabs as I scroll through. After the level adjustment, we did WRR with the scan length captured and recorded, overview tab, followed by the 3 tabs showing the zooming. After the WRR were the summary plots, again, overview with tabs. And finally, the histogram plot, using, again, documenting the range with the overview and all of the tabs. So we now have our Word document after the analysis where we can have the results. And again, if we wanted to say, well, we are just interested in the overview WRR, we can click the file and notice a JPEG file will pop up. And here is the JPEG file showing the overview plot of the WRR. When we're done, we simply hit exit to close out the program. When we do that, we now have this folder showing all of the save figures that we need. In addition, we have these folders. As mentioned before, on every figure, there is a save figure copy to clipboard. I will show you how to do this for the histogram plot on the overview tab. You just simply hit copy to clipboard. In this case, I will open up a Word document. Here is my NDT template that I will use. And all I need to do is right click and paste. I can paste either as a picture or I can keep source formatting. So I will do this, and notice what you have is a pretty good plot. I will show a zoomed image of this. Word allows me to go up to 200%. I will show that. So you can have a pretty good zoomed image of, in this case, the overview tab. Now, if I click and do another space, what I could do is maybe say I want to go to really focus on this winding on drum damage. Select that tab, hit save figure, copy to clipboard, go back to my Word template. I have created a new space, and again here I could right click and I can insert. So now what I see is the first image. You can see I have my overview 0 to 26 meters roughly, and here I have my highlighted -1 to -9. That will conclude this video presentation of the NDT Care version 3.0 software. Thank you for your time. If you have any questions, please reach out to us using the contact information provided on the lower left corner of this slide. Thank you for your time.